Hey my Wholemood students, so today we are going to be talking about respiration and fermentation, which is a process that makes ATP. Before we get started into this video, I would like you to please hit that like, hit that share, hit that comment and tell me what you think about this video and what other videos you'd like me to make. Without further ado, let us get into today's video. A whole entire mood. So, the vlogation. As I said, we are going to be talking about fermentation and respiration. And as you can already tell that I have my terms and definitions we are going to be talking about and breaking down. And we have a diagram which we will use to explain the whole entire process. Okay, so now we have ATP. ATP, it is a nucleotide that stores potential energy in its covalent bond between its phosphate groups. So ATP is a nucleotide that is composed of ribose, meaning that it is an RNA, 3 phosphate groups, and nitrogenous base adenine, and it stands for it's adenosine triphosphate. Yes. And then we respiration is divided into two processes where we get aerobic respiration and then anaerobic respiration. Aerobic respiration is cellular respiration that requires oxygen, and then anaerobic respiration is cellular respiration that does not require oxygen. And respiration is a process that occurs in the mitochondria, and it produces ATP, and ATP is very essential in the cell because it provides the cell with the energy it needs to do its job. All right, and then with that said, we are going to explain and describe the mitochondria. The mitochondria is an organelle that produces ATP, and then ATP stores energy, right? And then whenever the cell needs this energy, the ATP breaks one of its phosphate groups, and then when it breaks one of its phosphate groups, energy is released and energy is liberated. All right, so then now, as you can see, we have the structure, and as you can see that the structure has two membranes, which is composed of an outer membrane and an inner membrane. So these membranes, they protect the cell, and they separate the organelle, and they separate the organelle from the rest of the other organelles in the cytoplasm. And obviously around is what we call the cytoplasm. All right, and then now inside the organelle we have another membrane, which is called the inner membrane of the mitochondria, and then folds of this membrane are called cristae. Okay, and then the space between the inner membrane and the outer membrane, this space is called the intermembrane compartment. And then the space inside the membrane is called the matrix. The space inside the inner membrane is called the matrix, and then these folds are called cristae. So a mitochondria has an inner membrane and an outer membrane, and then it has two outer membranes, an inner one and an outer one. Then it also consists of an inner intricately folded inner membrane, and then it has the intermembrane compartment, which separates the outer membrane and the inner membrane, the two membranes, and then it has cristae, which are folds of the inner membrane, and then we are going to describe the processes of respiration. We have glycolysis. Glycolysis is a universal process because it occurs both in aerobic respiration and anaerobic respiration. This is a universal because it does not require oxygen, meaning that it can occur in places that have oxygen and in places that don't have oxygen. And what happens in glycolysis, the cell spins ATP. It spins the mitochondria spins 2 molecules of ATP to generate glycolysis. And then what happens over here, so let us put down how respiration is made. So now cellular respiration, what we are doing is we are breaking glucose, right, to produce energy. Okay, so then it is essentially the reverse of photosynthesis. So then now we have C6H12O6 plus we will obviously use oxygen plus 6O2. It is going to give us 6CO2 plus 6H2O plus ATP, right? So then now in glycolysis, the cell uses 2 molecules of ATP already, and then those molecules of ATP helps to break down this glucose molecule, and this glucose molecule is broken down into 2 3-carbon molecules that are called pyruvate. Okay, so then now it uses 2 molecules of ATP from the mitochondria, and then after it uses them, it breaks the glucose and it forms 2 molecules that are called pyruvate molecules, and they are 3-carbon molecules. So as you can see that glucose is a 6-carbon molecule, it is broken equally to produce 2 other carbon molecules. And then now we are gonna have so these are like the 2 carbon molecules that are produced, okay? And then in the same time, when the whole process is done, glycolysis produces 4 ATP molecules and 2 NADH molecules. NADH molecules are molecules that carry energized electrons. They carry energized electrons, and then so what glycolysis gives us, it produces 4 molecules of ATP, but then remember that it used 2 molecules of ATP already. So now the net overall we have 2 molecules of ATP because it made 4 but it used 2, so then 4 minus 2 is 2, so then the net is 2 ATP molecules and 2 pyruvates and 2 NADH molecules, right? And then from there, glycolysis is over. So now we have covered what ATP is, we have covered what aerobic respiration and anaerobic respiration is, we have covered glycolysis where we made pyruvates, NADH and some more ATP. And then we also covered what the mitochondria is and all of its compartments. And in compartments, it includes cristae, intermembrane compartment, the matrix, outer and the inner, and then we have the cytoplasm which surrounds the membrane, the membranes of the mitochondria. And then this is the whole reaction that gives us ATP, whereby we break down glucose using oxygen, and we have the products of water, carbon dioxide and ATP. So then now that we have made our we have made this product, it goes on to the next step. So the next step is called a transition step, a preliminary transition step. So now, before we go into the Krebs cycle, which is the next actual step of respiration, we go through a transition step. The transition steps, since you see we have two molecules of pyruvate, it spins, it takes, it loses, let's just say it loses a carbon dioxide. Carbon dioxide is released from the pyruvate. Carbon dioxide is released from the pyruvate. And then so if our pyruvate was 3 carbon molecules, and if the carbons are removed, we are going to have two molecules that compose of 2 carbons, and then these carbons, they join with a coenzyme, right? A coenzyme, and then when they join with a coenzyme, they become acetyl CoA. It is called acetyl coenzyme A, but we can just call it acetyl CoA. So what happened? The carbons were released, well, carbon dioxide was released from the process whereby we got this, all right? And then 2 further molecules of NADH are produced. So we have 2 further NADH molecules, all right? Now the acetyl coenzyme A, so the glycolysis occurs in the cytoplasm, and then the 2 acetyl CoA molecules, they move into the mitochondria, through the membranes, through the intermembrane compartment, and then they go into the matrix. And then in the matrix is where the Krebs cycle occurs. Okay, and then the Krebs cycle, what happens in the Krebs cycle, the acetyl CoA sheds and loses its coenzyme, right? So now it is just 2 molecules of carbon, and and then what happens there, we get so now we just covered acetyl CoA, right? Now the acetyl CoA, it sheds its coenzyme, it sheds it, and then it becomes 2 molecules of carbon. And the 2 molecules of carbon, they react and they combine with a 4 carbon molecule called oxaloacetate. So now remember, this is 2 carbons and this is 4 carbons. You see now how many carbons? Now we are mixing a molecule with 2 carbons with a molecule with 4 carbons, and then what we get is a 6 carbon molecules called citrate. The Krebs cycle is also called the citrate cycle because citrate is the first product that is made. So if it is called the citrate cycle or the citric acid cycle, just know that they're also speaking about the Krebs cycle, right? So now in the Krebs cycle, other reactions occur whereby we get the 6 carbon molecule, but then in addition to this 6 carbon molecule, we get the cell produces more ATP. So it will, well, the first thing that happens, all the carbon molecules are released as carbon dioxide, né? So then the carbons are released as carbon dioxide, and then now we produce more ATP. Krebs cycle produces more ATP, and it produces two ATPs, and then it produces 6 NADH, which carry energized electrons, and then it produces 2 FADH2. They also carry energized molecules, right? So then after this, the cycle repeats itself, whereby the original oxaloacetate molecule is regenerated again, and it repeats the steps. And then the two carbon molecules of the acetyl CoA, the carbon molecules, they are released from the cell as carbon dioxide, and then we make 2 ATPs, 2 NADHs, and 2 FADH2. So far we have made 2 ATPs from the Krebs cycles and 2 ATPs from the glycolysis, making 4 ATPs. So now the net that we have is 2. We have 2 ATPs, and then we made 2 NADH from glycolysis, 2 NADH from the transition steps, and 6 from the Krebs cycles, which gives us 10 NADH. And then we have 2 FADH2 from the Krebs cycle. And then these two molecules, they carry energized electrons. And then now what happens? No, it's not 2, sorry, it's 4. The ATP is made, and then it will be used by the cell as what do you call this? For energy, when the cell needs energy. But then now what happens to this? These two, NADH and FADH2, they move on to the next step, which is called the electron transport chain, right? So we have covered this, and now we are going to the electron transport chain. The electron transport chain is a group of proteins that shuttle electrons from carrier to carrier. Okay, electron transport chain is a group of membrane proteins that are found on the membrane, and they transfer electrons from carrier to carrier, right? And they will energize the electrons. So now, the electron transport chain occurs in the membranes of our mitochondria. And then as you can see, the glycolysis stage occurred in the cytoplasm, and then our next step, which is called the Krebs cycle, occurred in our matrix. And then now the last step, which produces most ATP that is made in the cell, occurs in the membrane of the mitochondria. Right, one mistake I made, they don't occur on this membrane. The electron transport chain occurs in the inner membrane, right? It occurs in this membrane, not the one that protects the cell, but it occurs in the inner membrane, okay? And then what happens there, these two molecules which carry energized electrons, they come to the inner membrane, and they come to the transport proteins of the electron transport chain, and they put their cargo there, and then their cargo is transported within. And then what happens in that situation, electrons, so the first protein in the electron transport chain to accept is this one, and it will accept, it will get reduced by the electrons from NADH, and then NADH is oxidized. And then the second protein will accept electrons from FADH2, okay? And then these electrons move along the proteins, the chain from protein to protein, until they get into the last protein. And the last protein that accepts electrons, that is reduced, is oxygen, and then which combines with hydrogen to form water. And then within the electron transport chain, we get, so let us say this is our membrane, and then these are our chains, and then we have another membrane, then over here we have, so this is our chain, and then our electrons pass from this chain into the other chain, and then as these electrons move, these electrons release, through the help of the proteins, they release energy, and this energy are in the form of protons, and then these protons are called hydrogen ions. So they release, right? And then now these protons go into they fall into the intermembrane compartment, and then in the intermembrane compartment there is another enzyme. This enzyme is called ATP synthase. ATP synthase pulls and pumps these electrons out of the intermembrane compartment, and when they are pumped out, that is how we get our ATP, right? So now when they come out, they come out as hydrogen, and then they mix with ATP plus a phosphate to create our ATP. So now these protons are pumped out of the ATP synthase, and ATP synthase is the enzyme that produces ATP. And as they come out, ATP mixes with a phosphate, and then we get our ATP, and this is called chemiosmotic phosphorylation, whereby we are producing ATP through the help of the ATP synthase. And then substrate level of phosphorylation is when we are making ATP by electrons from a donor molecule. That is how they are different. The Krebs cycle and glycolysis produce ATP by substrate level phosphorylation, and then the electron transport chain produces ATP by chemiosmotic phosphorylation, whereby they use the ATP synthase to produce the proteins. And then now that is how we make our ATP. And now remember that these energized molecules with energized electrons, they come into the protein transport chain, and then they give their cargo to the electron transport chain. Then the electron transport chain moves this electron, and while it moves these electrons, it releases energy, which forms a potential energy gradient. And then this potential energy gradient, it is pumped out of the ATP synthase, whereby when it is pumped out the ATP synthase, ATP and a phosphate come together to create our ATP, and then the rest of these electrons, they mix with oxygen, and the oxygen mixes with hydrogen to form water, which is a product of respiration. And then now the electron transport chain produces a whopping of 34 ATP molecules, right? 34 ATP molecules. So now the Krebs cycle, glycolysis makes 2 ATPs, and then the Krebs cycle also makes 2 ATPs, and then the electron transport chain makes 34, which gives us a total of 38. But usually the amount of ATPs that are made is 36 ATPs. This is because for NADH to move, well, for the two molecules of NADH to move from the cytosol to the matrix, it uses 2 molecules of ATP, right? That is why we have a net total of 36 ATP molecules, and that is how ATP is made by the process of aerobic respiration. And then in anaerobic respiration, it's pretty much the same as aerobic respiration, but the final proton acceptor is a compound other than oxygen, and sometimes it is a phosphate, sometimes it is a nitrate, sometimes it is carbon dioxide, depending on the environment and the condition. And then now anaerobic respiration produces less ATP than aerobic respiration, and then anaerobic respiration it also it is also part of fermentation, whereby electrons from NADH reduce the pyruvates. And we have two types of fermentation. We have lactic acid fermentation, which occurs in our bodies, and alcoholic fermentation, which is used to make alcohol. And that concludes our video about respiration and fermentation. Thank you very much for watching. I hope you learned a thing or two. All the best on your test, your exams, and your classworks, and everything that you might require this lesson for. Thank you very much. I cannot wait to see you in the next video.